In this video, I'm going to go over the interval reporting based upon frames or bursts. The idea is that that instead of having the server report or the client report outputs, the interval reports based on time, you actually based upon sort of packet events or frame or completion of a frame. Frame is a series of packets. So the framing is the concept of video frame. I think this will be useful, particularly for things like VR, AR type environments, where the latency is going to start to matter, and you want to sort of see a worst case latency within a burst. And the other thing that's nice about it is you'll get the speed of the burst. It won't be averaged out across all the bursts. You'll get the speed of one burst, and you'll get the latency of one burst. So if to use the frame option, you have to use minus F, or sorry, F. It's minus I, then put the F or a character F to indicate that you're interested in frame reports, frame interval reporting. And then that should start it up. Actually, I don't have the TCP working quite yet, so I'm going to use UDP for this one. So let me do a quick clear over that. The other thing to remember with UDP, if you're doing to do latency-based testing, you want to have your clock synchronized. And so, like I said, I've said in other videos that these clocks are synchronized to the GPS atomic clock. So, I would suggest doing that particularly for test systems. So let's start that up again. Okay, and clear here. Now the idea is that since I want to test video frames, I'm going to have to create the frames. So that's using the isochronous option, which we went over in another video. On this one I'll output in seconds, but on the server I'm outputting in frames. Let's do 60 frames per second. So you put the minus isochronous, which is a long option, equal 60 frames per second, and for grins I'll do, like, this is a 10 gig, so I'll do a 1 gigabit per second burst with let's say 100 meg standard deviation. That'll be a log normal distribution, and I think that should be enough to do it. Let's see what happens. Okay, yeah, so now you see them blasting out, tons of stuff going through. So at 60 frames per second, the output of the server is just spewing by. And the thing to note is that this calculation is kind of interesting because of it's a gigabit per second, but there's going to be time, how the packets actually traverse end to end is kind of interesting. But or it might be a bug actually. I'll have to check that out. But anyways, the point is that what you're noticing is that the frame here, it gives you the beginning of a frame and the end of a frame instead of being time based. So a frame came in at this time and then finished, that frame completed at that time. And I will, for convenience, go ahead and put the delta. So that's like 7.1 milliseconds. This gigabit per second was the speed of the burst, which I need to double check and see if that's a bug or not. And then this is the distribution here of the packets, of the latencies of the packets, which starts with average, min, max, and standard deviation. So this is 125 microseconds, and this is your packet distribution within that burst. So anyways, the frame interval reporting will be interesting for things like Wi-Fi devices. When you move from one stream to two stream, you expect latency to go in half. So something like a VR AR game, you're going to expect rotation of the headset to not necessarily affect the range or the distance from the AP, but you will maybe expect sometimes that the stream will go from one to two streams and back, and so that should be seen in latency distributions. The other thing you might want to do with frames is go ahead and enable the histogram option, which will give a full histogram, not just mean, min, max. So let's set that with a 10 microsecond bin and see what happens. Let's see if we go. So these are going to blow by, but basically they're the full histograms, and you can look at each particular frame. Probably the best way to do that through scripts and do analysis of that as they flow by. And remember that even though that the I/O is happening, it's not impacting the performance, because the way iperf 2 is designed, all the I/O is done through the reporter thread. So the traffic threads are producing the timestamps. So the timing should be accurate. So don't worry about, oh, I got a ton of I/O going to the screen. That shouldn't impact the measurement of the tool.